Hello and welcome to my paradox presentation. Today I'm going to be talking about paradox, giving you a few examples, explaining how they work, why should you care, and what role they play in our society nowadays and in the past. So let's start from the beginning. What is a paradox? Well, a paradox are two ideas that at first glance don't make sense. They shouldn't add up, they shouldn't really make any sense. But when you pay attention to it or when you rationalize it, they do make sense and they do add up, even if they're not supposed to. And that's a paradox. Why should you care? Why should you care about paradox? Why should you care about any of the scientific mumbo jumbo they appear to be, but they're not? Paradoxes are important. They tell us about our history. They tell us about things we do not completely understand. And working around them is a way to fix many of the problems of past, modern, and future science, which goes back to paradoxes being part of our history as a whole. They have been with us since ancient Greece, to Italy in the Renaissance time, to Germany in World War II, to modern comedians, to economy, physicists, economists, chemists. They have been with us since the beginning, and they have been creating paradoxes with their theories. And working around them was a way to fix them, was a way to show us we did not fully comprehend what we're talking about. Now, let's start with one of the oldest paradoxes we have a record of, the Zeno paradox. The Zeno paradox goes like that. Suppose you want to go to your fridge, and it's 1 meter away. Well, no big deal, right? You can just walk to your fridge. But instead of walking 1 meter, walk 500 meters. Then half again, 250 meters. Half again, 125 meters. You see the problem there? You're never going to reach your fridge. You're always going to be missing half of what you're supposed to walk. And for more ridiculous than that sounds, for 1,500 years, only in the 1100s, someone called Fibonacci found a way to add infinite sums and prove you could finally reach your fridge. Incredible, huh? For almost 1,000 years, we did not know how to explain that you could reach your fridge that was 1 meter away. Going to time paradoxes. This is one of the most famous time paradoxes, the grandfather paradox. The grandfather paradox goes like that. A man meets his wife in the 1930s. He has a son. His son meets his wife. They have another son. And this son, let's call him Jake. Jake goes back in time, and when he's in there, he goes to the time before his grandfather met his grandmother. What happens is that Jake shot his grandfather before he met his grandmother. Now, Jake was never born because his grandfather never met his grandmother. You see? But if his grandfather never met his grandmother and he was never born, he couldn't have gone back in time and shot his grandfather, leading to his grandfather meeting his grandmother, and therefore he being born and shooting his grandfather. You see, you're going to create an infinite loop there of him not being born and shooting his grandfather. That's a paradox. It's called the grandfather paradox. Another time paradox is the bootstrap or iPod paradox, as it's being recently renamed. Suppose you have an iPod from 2001, okay? It was the year the iPod was released. And you decided to go back in time to the 1999. What happens then? You show your iPod to Apple before they have their own iPod model. And they say, whoa, let's use your model. It's ready and it works. And it's a great idea, as we all know. Well, that means that the guy who was going to create the iPod never created the iPod to begin with, because they're using your idea. But you didn't create the iPod either. What does that mean? Well, that means that information was created out of nowhere. Nobody had the iPod idea. The guy didn't have it, and you certainly didn't. Information was just created from nowhere, and that's an issue. Information cannot come from nowhere. And that's the iPod paradox. Now, what are some solutions for today's paradox? Many people have said and give many ideas on how to solve many of them. But as time travel is only a theoretical thing right now, they do not really work. So the multidimensional theory, things are not happening in the same timeline. Therefore, you can't shoot your grandfather. Or the impossibility theory. Things that create paradoxes are simply impossible, and messing up with them wouldn't work at all. The paradoxes solve themselves. Jake would never shoot his grandfather because the paradoxes wouldn't let it happen. They would just solve itself, they cancel each other out. Or the one that most people use as an explanation, we do not fully understand the question. Just like Zeno paradox, we didn't know how to add infinite sums, and that's why the paradox existed. It can be the same thing with time travel. We do not comprehend what we're talking about yet. So it may be that when we finally solve the issue, we will be able to time travel properly without creating those paradoxes. So there's a list of paradoxes. And these are not only on time travel, economy, chemistry, physics, relativity, all of them. They all are englobed here. And that's just a short list. You can Google thousands of different paradoxes in all fields of studies. And they're all going to tell you something. They are going to be a thought experiment most of the times, yes, because most of them have no practical use. But they're still going to be important for you to realize what you're doing and how things can be bent. And I really encourage you to look for it, because you learn more with them. So I just want to say that thank you for watching, and I hope I have encouraged you to take a step in this topic that is paradox.